Welcome to How to Become a Production SQL Database Administrator. My name is Raphael. In the previous video, I demonstrated to you and gave you an example of what a clustered index was. And that is that it stores the data in a column that you've specified to be clustered. The other thing that I want you to note is that when you have a table that does not have any form of indexes, it's referred to as a heap. And the other pointer that I want you to take note of as far as clustered indexes, that it does not require any additional physical disk, because when you're using a clustered index or creating a clustered index on a table, it's basically rearranging the data that you've specified in your clustered index. So no additional space is needed. However, when we're talking about non-clustered indexes, a couple of things are worth noting. A non-clustered index does have a structure separate from the data rows. And what I mean by that is as follows. So let me go to my web. You'll notice that this is obviously a table of contents. And this is an index also. And you'll notice that when you go, a classic example of a non-clustered index is an index in the back of a book. So if I were to ask you to look at the page, look at the keyword abandonment in a book, and you didn't have an index, what would you have to do? Well, you'd have to go to page 1, line 1, and look at the word abandonment. And you have to scroll through each line, through each page, finding the word abandonment. And suppose you found that word abandonment fairly quickly on the first page. So have you found all the keywords abandonment? And you haven't. So what you'll have to do without an index of any type is go through page by page by page, finding the keyword abandonment. And there may be 1, 2, or 10. So obviously it's going to be a tremendous amount of effort for you to go through the whole book page by page looking for the keyword abandonment. So this is where indexing comes in, and specifically non-clustered index. So when you create a non-clustered index, it's like having an index in the back of a book. Now, if I were to ask you to find the keyword abandonment, you're not going to go through the first page line by line looking for the keyword. What you're going to do is go to the very back of the book. You're going to go to this index, which is a separate entity than the whole book. So you've got additional pages, therefore you've got additional disk space being used in the SQL. So now you're going to go to the index. You're going to look at the keyword abandonment, and you'll notice that it has a pointer, which is the page number. It has so we know that the keyword abandonment is on page 12 and on page 19. So rather than doing one by one page, you'd go immediately to the page 12 and scroll down until you find the keyword abandonment. Then you're going to go immediately to the page 19 and scroll down and find the keyword word abandonment. And as you can see, finding these two keywords using an index, a non-clustered index, which is a separate entity than the data itself, which is the book, is much faster than going through page by page if you had a 100-page book. So obviously you can understand the great benefit now of what an index does and a non-clustered index does. So a clustered index basically organizes the data, and we can see that here. You can see that here when we clustered today, we created an index, clustered index on the last name, and you can see it's alphabetized. So now when you have a clustered index, and I asked you to find all the names with Angela, rather than going through the entire row by row, you will easily go start from the top, go all the way here, and you'll find the word keywords Angela. Now the benefit obviously is that Angela is right next to another key Angela, so you don't have to look for the entire table scan. So in this particular case, you will just stop here as soon as you find Angela, and then stop here, and you'll get your query. And we'll go over that in a second here. I don't want to go into the properties of indexing yet. I just want to illustrate what a non-cluster and a clustered index is. So that's what the clustered index is. So back to our little... So now you understand the benefits of having a non-clustered index, in that it allows you to retrieve data extremely fast by using this index. And the key thing to remember is it takes up space. And that's an important concept we'll get into in a second. So now let's go back to my SQL and review a few things. So in the previous video, we created a clustered index on the last name. And as you can see, it's being organized here, as we illustrated previously. So now what I want you to note is that I'm going to try to create another clustered index on a different column. This time I'm going to create a clustered index on first name. And as I mentioned, one of the properties of a clustered index is that you can only have one clustered index. So when I create this, now I'm using a clustered index on first name. So I'm going to go execute. And you'll see I get this error where it says cannot create more than one clustered index on table phone book. If I want to create another index, then I have to drop the existing one and recreate it. So what I am going to actually do is I'm going to drop it. So if you go here, here, expand it, refresh this, you'll see that I have the index here. So I'm going to drop this index. I can just right click it here and just delete it. And there we go. So one thing I do want to point out is that while I've illustrated that on a clustered index you can only have one clustered index, you can, however, have multiple columns using a single index. And I'm going to illustrate that right now. So here, create clustered index, index name, first name, last name. But here, note, I'm using two columns. So I can still have a single clustered index with multiple columns. So let's create that index, execute. And now let's look at the data and see what happened to those two fields, to the last name and to the first name, because that's what we created, a single clustered index. You'll notice that in the last names, obviously they're alphabetized. A to Aaron, B, C, A, scroll down, B, 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 C, 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 and so on. And we have already seen that. But since we've also created a non-clustered index on the first name column, what happens to that? Well, what's happening there is we've indicated, hey, take this column and make it into an ascending order after this. So let's look at some of this. So let's look at example Abigail. The creation of a clustered index on the first column, which is last name, is alphabetized, and there it is, Abigail. And then it says take the second column, which is the first name, and alphabetize that in order. So you'll see that Abigail is organized here, but then you'll see that C, then M is followed. So this is organized within these three names. And if we go to another one, for example, let's go to Brent, for example. We have three Brents organized, and here A, B, and L. So this has been organized also within this name. So that's what a multiple column does on a clustered index. So now let's look at non-clustered index. So I just wanted to point that out for you. So let's look at the data again. And now I'm going to give you an example of a non-clustered index. Obviously, you'll note that if I refresh this, you'll note that I do have a clustered index, as you can see. But we've also indicated that when you're creating a non-clustered index, you can have multiple clustered, non-clustered indexes. So here, the syntax is virtually identical with the exception of non. So I'm going to create non-clustered index, NC for non-cluster index, table name, and followed by the column name. And you can see, notice that after the creation of a non-clustered index, the data is not sorted. Well, I'm going to create, actually, let me drop this first because I want you to illustrate that. So let me just drop that. And actually, let me create an index on, because I want to make it phone book ID. Oops, ID. So sometimes you have to illustrate these points. So let's look at that. I want it to be original the way it was. And I'm going to create it on the primary key. So now if I look at the data again, you'll notice that it's the way it was prior to me having a cluster index on last name. Because the reason I want you to, the reason I'm showing you this is that when I create a non-clustered index, what happens to the data? So I'm going to create a non-clustered index on first name. So notice the first name column here, Angie, Kaisha, Carrie, Sherry, and so on. So now that I create a non-clustered index and I look at the data, nothing happens to the data in terms of organization. It's exactly the same. However, in the background, there has been a index created for this column. And so let's look at this. Another thing to note is that I can create multiple non-clustered indexes. So now I'm going to create a non-clustered index, second creation of an index on the phone. And I'm going to scroll here, highlight, execute. And if I look at the data again, you'll notice that the data in itself has not been reorganized or shuffled. However, in the background, you can't see the index, but quote unquote, you can't see the index, but the data has not been sorted. However, a separate index has been created, if you will, here, which has pointers. And I'm going to be going over that concept in a second, of what actually indexing does. But right now, it suffices to know that you can create multiple non-clustered indexes. That non-clustered indexes take up space. They do not reorganize the data, but they have separate entities, much like this in the background, that allows you to retrieve data extremely fast. So I think I'm going to leave it here, and in the next video we're going to talk about composite indexes. Then after that, I'm going to bring all this together so you'll have a clear understanding of what the purpose of index is, and we're going to illustrate that also. So I'm going to provide all this syntax for you, so you don't have to worry about that. So I think I'll leave it there, and we'll continue with indexing in the next video. So my name is Rafael, and this is how to become a production SQL database administrator.